Welcome to The Explainer. Today, we're going to uncover the hidden science inside one of the most important and maybe most overlooked devices in your entire home.
So let's start with a simple question. We all have a smoke detector, right? It's that little box on the ceiling. But have you ever really wondered what's going on inside when it starts screaming? How does it actually know there's smoke in the air?
Well, the answer is pretty surprising, and it all comes down to some amazing physics. Get this, the whole thing works because of about 0.0002 grams of a man-made radioactive material. Yeah, you heard that right, radioactive. That means you have a tiny piece of a radioactive element in your house. But hey, don't worry. It's an incredibly small amount, it's perfectly safe, and it's absolutely essential for how this whole thing works.
To really understand this, we need to shrink ourselves down, like way, way down, smaller than any microscope can see. We need to talk about the fundamental building blocks of, well, everything.
Everything you can touch, see, or feel is made of atoms. But an atom isn't just a tiny solid ball. It's more like a mini solar system. It has a super dense core, called the nucleus, and then it has these incredibly light particles called electrons just buzzing all around it in something we call an electron cloud. So let's meet the three key players inside the atom. In the nucleus, that dense center, you have protons, which have a positive charge, and neutrons, which are, you guessed it, neutral. These two are the heavyweights. They make up almost all the atom's mass. Then, on the outside, you have those tiny, negatively charged electrons whizzing around. The whole secret to chemistry is really just the push and pull between these positive and negative charges.
Okay, so if everything is made from just these same three particles, how is something like gold so different from, say, the oxygen we're breathing right now? What makes an element what it is?
It all comes down to one thing, the number of protons. The proton count is like an element's social security number. It's its unique, unchangeable fingerprint. An atom with one proton is always hydrogen. An atom with 8 protons is always oxygen. And an atom with 95 protons? Well, that's always our special ingredient, americesium.
So that brings us back to our key ingredient. The name itself, American 241, gives us a pretty big clue. We know the American part means it has 95 protons. So what's that 241 telling us?
And this is where we get to talk about isotopes. You can think of them as different versions, or maybe flavors, of the same element. They have the exact same number of protons, so their identity is the same, but they have a different number of neutrons in their nucleus.
Let's use nitrogen as an example. It makes it super clear. Both of these are atoms of nitrogen because, look, they both have 7 protons. That's a fixed rule. But nitrogen-14 has 7 neutrons, while its cousin, nitrogen-15, has 8. That one extra neutron changes its total weight, what we call the mass number, and that gives them slightly different properties.
And that's exactly what's happening here. The 241 in americium-241 is just its mass number, the total count of its protons and its neutrons all added up. It tells us we're dealing with one very specific, and in this case, radioactive version of americium. And this is the isotope that's absolutely perfect for a smoke detector.
We are so close. We just have one more little piece of the puzzle to understand before we can finally crack this thing wide open. We need to talk about how atoms, which are usually neutral, can get an electrical charge.
You see, an atom is normally balanced. It has the same number of positive protons and negative electrons, so their charges cancel each other out. An ion is what happens when that perfect balance gets all thrown out of whack.
So let's just walk through it. Imagine a neutral atom, just minding its own business. Then bam, some kind of outside force comes flying in and knocks one of its negative electrons away. Well, now the atom is unbalanced. It has more positive protons than negative electrons, and that gives it an overall positive charge. It has just become a positive ion.
So the key thing to remember here is that this whole process, becoming an ion, is all about gaining or losing electrons. Why not protons? Because the protons are locked away safe and sound in the nucleus. The electrons are on the outside, in that buzzing cloud, making them way easier to knock off or to grab.
Okay, there we have it. We have all the clues. We know about atoms, we know what an isotope is, and we know how ions are made. So let's go back to our smoke detector and finally solve this mystery.
So, inside a small chamber in the detector, that tiny bit of americium-241 is constantly and steadily shooting off these little energetic things called alpha particles.
Now, those alpha particles are the outside force we just talked about. They fly out and they collide with the air molecules inside the chamber. just normal oxygen and nitrogen, and they ionize them by knocking their electrons right off. This creates a constant, steady supply of charged ions in the air.
Inside that same chamber, there are two metal plates with an electrical charge, one positive and one negative. And since opposites attract, all those newly created positive and negative ions start to flow towards the oppositely charged plate. This movement, this flow of ions, creates a tiny but very steady and measurable electric current. Everything is calm. The circuit is complete.
But then, here comes the smoke. This is the critical moment. When smoke particles from a fire get into the chamber, they're much bigger than the ions. They get in the way, they attach to the ions, and they basically neutralize them, breaking that smooth, orderly flow between the plates.
The detector has a circuit that's constantly monitoring that tiny electric current. The instant it senses that the current has dropped because the smoke has disrupted the flow of ions, it knows something is wrong. That drop in current is the trigger. It breaks the circuit, and that's what sets off that incredibly loud alarm that saves lives.
So the entire life-saving trick is based on this beautiful piece of physics. You create a tiny, invisible current out of thin air, and then you just listen for the moment that smoke breaks it. It's a silent guardian, running 24/7 on atomic principles. It just goes to show you how this fundamental atomic science is powering our world in ways we barely even notice. I think the big thing you should take away from this is that the most important, world-changing effects often start at the very smallest scale. The atom in your alarm is proof of that.